Okay, so we are recording, y'all. Let's see. Glad everybody's doing well. So, y'all, we are in week 4. Okay, so week 4, y'all. One thing I had mentioned before, I did have printed copies of notes for chapters 1 and 2, but I was not going to bring them in after that. So, if anybody wanted to get access to notes, they are right here. If you click on it, you should be able to download the notes. So, if you want to use like your iPad or something like that, or just download it to your laptop, that's fine. If you want to print them out, y'all, next door is the CLE, and you can print there. So you can just like download this and print it out. But let's take a look at what we're doing this week. So let's see. Today, y'all, I'm going to go over section 3.1. I'll upload the video today by 5 o'clock, if not earlier. I've been usually doing it right after our class. And homework for 3.1 is due by Monday, next Monday, okay? Let's see. Wednesday, y'all, will cover section 3.2. All right, and we do have a written class assignment, and it says complete class assignment 1 found here. So again, y'all, if you want, you have some options. You can click on it here. You can work out, it's only 4 questions. You can work out these problems on your own paper if you want to, or you can print it out. It's up to you, whatever you want to do. So again, right here, you can choose to print it out, work out each problem on your own paper. Once you've completed it, guys, you can send it to me via Blackboard messages. So what you would do is, up here at the top, let me go to the student preview. Yeah, we'll leave it like this. You'd send me a message here. So you would, do this, and you should be able to put my name, and you can put an attachment, right? So you would do it that way, or your other option is to simply just turn it in to me in person, since we do meet in person for our class. It's due by Wednesday the 21st, which is not this Wednesday, but next Wednesday. Okay, so you got a week and a half to do 4 questions. So again, y'all, it's up to you. Obviously, if you turn it into class, turn it in when we have class, right? But if you want to sit, if you don't finish it, by the time class comes around on next Wednesday, you can just send me like a picture, you can save it as a PDF or a picture file and just send it to me through Blackboard messages, okay? But again, it's just 4 questions. So, all right, let's go ahead and get started with what we're going to do today. So again, chapter 3 notes right here, y'all. And what I've done is I've uploaded them here. So let's go through 3.1. So y'all, 3.1 talks about these things called numeration systems. And what we're doing here in 3.1 is the number system that we've always used, or that we normally use here, is something called the Hindu Arabic numeration system. And all numerals are constructed from 10 digits. So the digits that we have are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And our place values are based on powers of 10, right? So again, if you think about, we talk about place values before, right? We did that like in elementary school. And so we use the number 10 base system, okay? So it says, first thing we have, definition of a to the n. So a to the n is just repeated multiplication. So a times a times a, we have so many of them, n factors, we write that as a to the n, right? Okay, so when we talk about base 10 system, y'all, we have like the ones, the tens, the hundreds, and the thousands, right? And if you think about what we learned probably like in, first grade, second grade, third grade type stuff, we learned how to count using like little blocks or these kind of longs or flats or cubes or whatever. And so we have some definitions right here, and it says 1 unit is 10 to the power 0. A long is 10 to the power 1, which is 10 units. A flat is 10 squared, which is either 10 longs or 100 units. And a block is 10 to the third, which is 10 flats or 100 longs or 1,000 units, okay? And so what we're trying to do here is we're trying to see if we can figure out how to figure out which place value, okay? So it says indicate which digit in the number 2,659,324 has a place value shown. Okay, so first question. What digit is in the hundreds position? Anyone know? What digit would be in the hundreds position? Anyone know here? So remember, when I look at this number here, oops, sorry. When I look at this number right here, the hundreds, so what number would you say hundreds? Like if you were going to read this number, this would be 2,659,324. So what digit's in the hundreds position? The 3, right? Okay, what about the 10,000s? Where would we find the 10,000s? Anyone know? 5, right? So the 5, that's my 10,000s right there, okay? So there's my hundreds position and there's my 10,000s position, okay? All right, so I'm gonna kind of keep scrolling here. And it says, for the following decimal numeral, give the place value of the underlying digit. Okay, so what we're trying to figure out here, y'all, is the 6 is in what position? Is it the ones, the tens, the hundreds, the thousands, the 10,000s? What do you think the 6 is in? The hundreds, right? Good. Okay. So now, what we're going to do here, we're going to rewrite each of the following as a base 10 numeral. Again, remember the idea here is this is how you would sort of explain this to somebody who's in second grade or third grade or whatever it happens to be, right? So when I'm looking at something like this, y'all, and I'm looking at the first part, and it says 7 times 10 to the third. So 10 to the third, y'all, is going to be 1,000. Why? Because it's 10 to the third means it has 3 zeros, okay? Plus 5 times 10 squared is going to be 100. Why 100? Because it has 2 zeros. Why 2? Because that's what my exponent tells me, okay? Plus 20 times 10, okay? So let's keep working here. What's 7 times 1,000? 7,000, right? Plus 500 plus 20. And again, if you're thinking about how you would approach this, right, or how you would show this to kids, right, wouldn't you probably do something like this? 7,520. Wouldn't we try to line stuff up, right? I'm sorry? Yeah, and start bringing our numbers down, right? So look, when we would do this now, if we just add straight down, that's going to give me 0. If I add straight down here, that's going to give me 2. If I do this one here, that's going to give me 5, and then bring down my 7, right? So the answer is 7,520. But again, the idea is, how would I approach this, right? How would I show this to, you know, somebody who's 8 or 9 or something like that? Okay. Look, y'all, let's do the same thing for the second one. So for part B, when I start doing part B, I know I'm going to have 5 times. How many zeros do you think I should write if it's 10 to the 6? Anyone? 6 zeros, right? Okay, so look, let's go like this. 1, 2, 3, 4, 5, 6. Okay. And then 4 times 10, and then 2. Okay, so again, y'all, if I did this just like we did the other one, this is going to be 5 million. And that's going to be 40, and that's going to be 2. And again, if I was showing somebody how to do this, I would probably write something like this: 5 million. And then I'd probably put 40 right here, and I'd probably put 2. And I would just, again, line everything up and add straight down. So I know that's going to be a 2. I know that's going to be a 4. I got a 0 there. We have 3 more zeros and a 5, right? So my answer is 5,042,042. Okay. Okay, so now let's take a look at the next portion that we have here, and it says, write the following numerals in words. Okay, so we're trying to write the following numerals in words. Let's see. So again, y'all, I just want you to kind of think about the process here. Look, I know this is the ones, that's the tens, that's the hundreds, thousands, 10,000s, 100,000s. What comes after 100,000s? Anyone know? Anyone know what comes after 100,000s? Millions, 10 millions, and this would be what? 100 millions, right? Okay, so look, the way I would write this, I would say 800 million, or 800, sorry. million 255,000. I'm going to write it underneath because I don't have a lot of room here. $310. Oops, no comma. 10. Okay. So 875,255,310. Okay. So y'all, let's think about that. Let's think about the second one. Look, I know these are ones, these are tens, these are hundreds, these are thousands, 10,000s, 100,000s. What position did we say these were in? Millions, right? So millions, 10 millions, 100 millions. What do you think comes after millions? Billions, right? Okay. So look, when I'm going to do part B, we're going to say 88 billion. Okay, 88 billion. These next three digits here, y'all, I would say 200 or, yeah, 276 million 656,423. There we go. So again, all I'm doing here, y'all, I'm looking at the words the numbers that I have and trying to figure out which is the best word description for them, okay? So I have to know place values, right? That's something we absolutely have to know. We got to know place values, okay? Okay, so let's kind of keep scrolling on here. The next problem says, how many digits are in the number, or in the Hindu Arabic number form of 55,370 times 10 to the 25th? So y'all, it's not as simple as saying, look, let me take my calculator and let me turn it on and clear this out. I couldn't really say, look, 55,370 times 10 to the power 25, because if I were to do that, I would end up with this kind of notion here, right? And that little e to the 29th means that I would have to take this decimal, y'all, and move it 29 spots that way, okay? So the way we do this, y'all, is we say, how many numbers do we have there? Oops, why did I turn that off? Let me try this one more time. 55,370 times 10 to the 25th. Okay. Yes. Let me just double check something real quick, y'all. I want to make sure that I'm telling you the right way. Yeah. Okay. So the way we do something like this, y'all, we're going to say, how many digits do I have here? Anybody know how many digits we have? How many different numbers there? 5. Okay. And then we take our exponent here, 25. We add those numbers together, and that tells us exactly how many digits we're going to have. Okay. So all we're doing is just a counting game. We take the number of digits that I have here and take that exponent, add them together, and there's my answer. Okay. And the nice thing about that is I don't have to use my calculator. All I got to do is add. Okay. All right. So let me keep scrolling along here. Just 30, yeah. Just adding my numbers up. Okay. So y'all, the way we deal with our numbers on a daily basis is we have base 10 blocks. Okay. So the way we deal with numbers all the time is base 10 blocks. So we have, 1, 2, 1 all the way to 9. And then when we get to 10s, we kind of make that long, right? And then when we have 11s, we have one long and a single unit, When we get to 12, we have 1 long and 2 units, so on and so forth, okay? This is how we deal with numbers, right? Now, we have something called base 5 number blocks. So when we deal with base 5, y'all, I want you to look at when we're dealing with base 5, we have 1 unit, 2 units, 3 units, 4 units. When we get to 5, that's what we call our long. And look at how they write the number in base 5. It's 10 base 5. What that means, what that means when I see something like this, what that means is that these are the units, and these are the 5s. So what this means, when I look at this number here, this means I have 1 5 and no units, okay? When I look at something like this, y'all, in base 5, this means I have a single 1 and I have 1 5. So I want you to notice here, if I were to look at what I wrote right here, the 11 5, this means I have 1 2 3 4 5 6, right? So I have a total of 6 little units. But in base 5, our longs are only 5 units instead of 10, okay? So the idea here, y'all, is when we're dealing with base numbers of a certain base, whatever that base is, we never go past that number. We always go up to the number right before it. What I mean by that is if this here is a 5, the biggest number I'm ever going to write is going to be a 4. And then I go into the next place value, okay? When we deal with numbers in base 2, we're never going to go past 1. We're either going to write 1s or 0s because we're only looking in base 2s. So look, here's my block, there's my long. We start grouping in terms of 2. Here's a long and 1 more. Here's my little cube or my little square, whatever you want to call it, right? So again, y'all, the way we're doing these things here, we're looking at numbers in base 2, okay? And I'm going to kind of show you, and we even have numbers in base 12. So I want you to notice, in numbers in base 12, y'all, in base 12, we still have, we're never going to go past the number 12. So they call this is kind of like the 10, and that's kind of like the 11. And we're going to walk through this process, y'all, to kind of get the idea. But I'm going to show you how we're going to do some of these numbers here, okay? Okay, so it says write the first 10 counting numerals for each of the bases. We want to go base 5 and we want to go base 7. Okay, so we know what the first 10 counting numbers look like. We know that they look like this: 1 2 3 4 5 6 7 8 9. Oops, I forgot a 6. And 10. Okay. What we're going to do, y'all, we're going to group in terms of 5s, okay? So 1 is still going to be 1, 2 is still going to be 2, 3 is still going to be 3, 4 is still going to be 4. But when we have 5s, that's going to be my first number that's going to look like this. What this means, y'all, is that there's 1 5 and there are no single units, okay? When I look at the number 6, I want you to think about the number 6. If I was thinking about grouping in terms of 5, couldn't I think of 6 as 1 5 and 1 1? Because I have a 5 and a 1. If I add those together, that gives me 6. And I'm just going to try to give myself a little bit of room here because I forgot that 6. Okay, and if I think of the number 7, in terms of 5s, couldn't that be a 5 and, oops, not a 5, not like that, sorry. Wouldn't that be 1 5 and 2 1s? And how could I think of 8 in terms of 5? Anyone know? Think of what number do you have to add to 5 to get to 8? 3, right? So 1 5 and 3 1s? And how would I think of 9 in terms of 5? Well, 1 5 and 4 1s? And then how would I think of the number 10 in terms of 5s? How many 5s are in 10? 2. So 2 5s and no 1s, okay? So notice, y'all, we start writing out these numbers, and again, the way they write them, y'all, A lot of times, the way our book uses it, they actually write out the word 5, but I'm a little on the lazy side, so I'm just going to do mine like this. And the reason I put those 5s there is to understand that I'm in base 5, okay? So again, just to get the idea, to make sure that I'm making sense here and that what this really means. When I look at this number here, the 14/5, if I was to think about it as a number in base 10, which is how we always think about numbers, this would mean is that there's 1 5 and there are, and there are 4 1s, okay? So look, 1 times 5 is 5, 4 times 1 is 4, and if I add those together, that gives me my 9. Does that make sense? That's how I'm kind of thinking of these numbers, okay? So look, I'm going to do the same thing in terms of base 7. So the first thing I'm going to do, y'all, I'm going to try to give myself a little bit more room here. Why do I keep forgetting 6? I don't know. Okay. Now, I'm going to do everything here, y'all, in base 7, which means I'm thinking about 7s, okay? So in 1, 1 is still 1, right? I don't have any 7s yet. 2 is still 2, 3 is still 3, 4 is still 4, 5 is still 5, 6 is still 6. But if I start thinking about the number 7, in base 7, there is 1 7 and there are no 1s, okay? If I think about the number 8 in terms of 7, there's 1 7 and another 1, right? If I think of 9 in terms of 7, there's 1 7 and 2 1s. Anybody know how would I think of 10 in base 7? So if you were to take 10 minus 7, what would you get? 10 minus 7? 3. So 1 7 and 3 1s, right? And these are my numbers, y'all, in base 7, okay? Okay. And all I'm doing here is I'm just grouping in terms of 7, okay? So notice, whatever base I'm dealing with, if I'm grouping in terms of 7, the first numbers before that number base, whatever it is, so if I'm dealing with 7, the first 6 numbers are going to just be the same 6 numbers. When I was grouping in terms of 5, the first 4 numbers, 1 through 4, are still the same 1 through 4s, right? It's not until I get to the base number where I start carrying over into the next place value, okay? So, let's see. So look, y'all, when I'm dealing here with base 7, I want you to notice how many different digits we have. What I mean by digits, how many different numbers do we have? Look, we got 1, 2, 3, 4, 5, 6, but we also have what number? We also have the 0. So when I'm dealing with base 7, we have 7 digits, right? When I'm dealing with base 5, look at numbers we have: 1, 2, 3, 4. I never write a 5, but I do include the what number? 0. So whatever base I'm dealing with, that tells me how many digits I have. So if I'm dealing with base 5, I have 5 digits. If I'm dealing with base 7, I have 7 digits. So the next question says, how many different digits are used in base 20? What would we say? 20, right? There's still 20 digits, right? It would be 1 through 19, and then the number 0. Okay, so the next problem here says, write the number 21, 22 in base 3 in expanded form and then convert it to base 10. Before I do that problem, y'all, I want you to think about this number right here. Okay, and think about this number in base 10 like the way we've always thought about numbers. What place value is the 7 in? Anybody know? The 7's in what place value? Anyone? Thousands, right? Okay, so look, y'all, the way I'm going to think about this, this is 7 times 1,000, okay? The 5 is in the hundreds position. The 6 is in the tens position, and the 3 is in the ones position, right? Now, again, I'm kind of going backwards from the very first, one of the first problems that we did earlier today, but I want you to think about this number right here. 7 times 1,000. I know it's 7,000, but can I write 1,000 as 10 to the third? And can't we write 100 as 10 squared? And can't we write 10 as, say, 10 to the first, and then my 3? What I want you to think about is, and we don't think about this every day because we learned this stuff when we were in second or third grade, but this is, in reality, this is how we're doing this. When we're in the thousands position, because we're with base 10, thousands really is that base number, the base 10 that we've always used, to the third power. Hundreds are 10 to the second power. Tens are 10 to the first powers, and ones are just those digits themselves. So when I'm thinking about the number 21, 22, and base 3, I'm going to write it in expanded form, and then we're going to convert it to base 10. What I want you to think about is I'm going to work my way from the left to, from the right to the left. I'm going to work my way this way. So that number 2, those are like my ones, my units, okay? The next 2 is going to be the 3s to the first power, okay? That 1 is going to be my 3s to the second power. And then that 2, that 2 is going to be my 3s to the third power, okay? So when I look at this number 2122 or 2,122 in base 3, notice y'all, when we were dealing with base 10 before, 7,000, we really said, well, that was 7 times 10 to the third. Why 10 to the third? Because we were dealing with base 10. Now that we're dealing with base 3, this is how we're writing them, okay? Because we're dealing with base 3. So this is what we call expanded form, and we're going to convert this to base 10. So the first thing I want to figure out here, y'all, is what is 3 to the third? I know 10 to the third is 1,000, but I need to figure out what 3 to the third is. So I'm going to take my calculator here. Let me clear this out. I'm going to say 3 to the third power is 27, okay? And 3 squared. Well, 3 squared, I think I know 3 squared. 3 squared is 3 times 3, which is 9, okay? 2 times 3 to the first is just 2 times 3, and then we're going to add 2 to this. So now what we're going to do, y'all, we're just going to multiply and add the numbers up. So the first thing I'm going to do is 2 times 27, y'all, that's going to give me a 54, okay? 1 times 9 is still 9. 2 times 3 is 6, and we're going to add 2. And all I'm going to do here, y'all, is I'm just going to add these numbers up. So 54 plus 9 plus 6 plus 2 is 71. Okay. So the number 2,222 in base 3 is equal to 71 in base 10. Okay. And that's all we're doing. We're just going from one form to another. Okay. So in base 3, y'all, notice the numbers that I have, none of them are bigger than 3. They're all going to be 0, 1s, or 2s. In this case, we just had 1s and 2s, but we could have had a 0 in there if we needed to. All right. But again, this is sort of the game that I'm playing. I'm looking at my place values. Okay. All right. So for the next problem, I'm going to do the same thing here. It says, in what base does 44 with a particular base plus 36 with a particular base equal 113 with a particular base? Okay, so what I'm going to do, y'all, I'm going to start on this side right here. I'm going to look at that 44 with my base. So remember, the first 4 are my ones. So it's just a plus 4. The second 4 is telling me how many B's to the first I'm going to have, right? Okay, plus the 36, I'm going to do the same thing. The 6 are just my ones. But the 3 is telling me how many B's to the first I'm going to have, okay? Now, the 113, again, I'm going to work my way from the right to the left. The 3's are my ones. The 1 is telling me how many B's to the first I'm going to have. And this 1 is going to tell me how many B's to the second I'm going to have, okay? All right. So the first thing I'm going to do here, y'all, I'm just going to multiply. 4 times b to the first is just a 4b plus 4. 3 times b to the first is just a 3b plus 6. Okay. 1 times b squared is just a b squared. 1 times b is another b. And then we got a 3 right here. Okay. I'm going to worry about combining the ones that I know I can combine. Like 4b and 3b is going to leave me with a 7b. A plus 4 and a plus 6, y'all, is going to give me a plus 10. Okay. Is equal to b squared plus b plus 3. Okay. Now, what I want to do is I want to put all the numbers on one side and 0 on the other. So what I'm going to do here, y'all, I'm going to minus my 7b and I'm going to subtract my 10. Subtract my 7b and I'm going to subtract my 10. Okay. So let's take a look at what we got. Okay, so we have a 0 over here now. Now we have a b squared. All right, think about this, y'all, as a 1b. So 1 minus 7. If I had $1, but I owed you 7, does everybody agree I would still owe you 6? Okay. And then plus 3 and minus 10. If I have $3, but I owe you 10, I would still owe you 7, right? Okay, so now, y'all, what I'm doing here, we're going to factor this thing out. Again, we did some of the stuff in college algebra, but in case you forgot, I'm going to walk you through it. I'm looking for two numbers that multiply to a negative 7, but if I add them up, I get a negative 6. So I want you to think about that. Two numbers that multiply to negative 7. The only numbers that I know multiply to negative 7 are negative 1 and positive 7 and positive 1 and negative 7. I'm looking for the pair that if I were to add them up, I would get a negative 6. Which ones add up to a negative 6? Negative 1 and 7 or 1 and negative 7? Anyone know? Which ones add up to a negative? Yeah, these right here, right? Because this means, again, I have $1, but I owe you 7, I would owe you 6. So right here, y'all, I'm going to put a plus 1 and a minus 7. Okay. And now when we get to this stage, y'all, all we're going to do is set each factor equal to 0. So we're going to take this piece and this piece here. We're going to set them both equal to 0. So a b plus 1 equals 0 and a b minus 7 equals 0. From here, y'all, b is going to be equal to negative 1. From here, b is going to be equal to 7. The thing about my base, y'all, my base number cannot be negative. The base number tells me what I'm counting in terms of what. I can't count in terms of negatives. So at this stage, y'all, I would say the only answer we're going to have is the base number being 7. Okay. All right. So I'm moving along to the next problem here, y'all. And it says, let me just kind of zoom in here. It says, a certain game show distributes prizes that are in powers of 2. What is the minimum number of prizes that could be distributed from 978? Okay, so let me walk you through the process. All these numbers here, y'all, the 512, the 256, the 128, the 64, the 32, the 16, the 8, the 4, the 2, and the 1, those are all powers of 2, okay? These are all powers of 2. What we're going to do here is we're going to take the number 978, okay? And we're going to divide it by the biggest power of 2 that we had. Here we had 512, okay? Y'all, you don't actually have to do a whole lot of dividing here, but how many times do you think 512 would go into 978? Do you think it would go in twice, or is twice going to be too much? What do you think? Would twice be too much? Because if we were to take 512 and you were to double it, 500 times 2 would already give me what? What's 500 times 2? Anybody know? It would be 1,000, right? We got 978. So we know it's only going to go in one time. So look, y'all, I'm going to take 512 and I'm going to subtract this here. So let me take my calculator and let's say, what's 978 minus 512, okay? and I'm coming up with the number 466. I think it's what we got. Yeah, 466. Okay, so how many prizes could we give in 512? We could give one prize. Why one prize? Because it went in one time. Okay. Now, I'm going to play the same game again, y'all. I'm going to take that number 466 and I'm going to divide it by the next number I have, 256. How many times do you think 256 would go into 466? Do you think it'd be once? Do you think it'd be twice, 3 times, 9 times? What do you guys think? Once, right? Because again, if I were to double it, 250, if it was 250 and I doubled it, that would give me 500, right? So I know it's only going to go in one time, right? So 256 here. And again, we're going to subtract. So 6 minus 6 is 0. 6 minus 5 is 1. 4 minus 2 is 2. So I'm coming up with 210. All right, so I got my 1 right there. Okay. And I'm going to keep playing this game, y'all. I'm going to take my number 210 and I'm going to divide it by the next number, 128. Anyone have an idea how many times it might go in? What do you think? Once, twice, 9 times? What do you think? 128 into 210. 1 time again, right? Okay, cool. 128. All right, so I'm going to go 1 there. So let's go ahead, let's go ahead and subtract. Let me get my calculator. Let's see, we got 210 minus 128. I'm sorry, how much was it? 82. I'll put a plus instead of a minus. There we go. 82. Excellent. Okay. So now, y'all, I'm going to take a look at the next number, which is 64. Anybody know how many times 64 would go into 82? Once again, right? Okay. So look, if we were to do this, right, the way we've always subtracted, let's see, 12 minus 4 is 8. 7 minus 6 is 1. Okay. So we got 1 for our 64. Now, look, y'all, the next number I have is 18. Does 32 go into 18? No, it doesn't, right? You know that. I know that. So it doesn't go into 18. That's why that number there is going to be a 0. Okay? But we still have the number 18. Now I'm going to go to my next power of 2, which is a 16. How many times does 16 go into 18? 1 time, right? Okay, and I got a 2 right here. So I'm going to put a 1 right here. Okay? Now look, y'all, the next number I have is 2. Well, 8 doesn't go into 2, so that's got to be a 0. 4 doesn't go into 2, so that's got to be a 0. But 2 goes into 2 how many times? 1 time. And that number is a 0 right there, right? Because I don't have any remainders or anything. So that's going to go in 1 time. There's my 2, and my remainder is 0, right? And that's all I'm trying to do here, y'all. I'm just breaking this number down in powers of 2, okay? Breaking this number down in powers of 2. So, y'all, what we really did here, just to let you know, what we did is we said the number 978. Remember, this number here, y'all, was in base 10. What we did is we said that that number is going to be, I'm going to start writing my digits. 1, 1, so I have 4 1s and a 0. So 1, 2, 3, 4, and a 0. And then over here, I have 100 and a 10. So I'm going to write 100 and a 10. So 978 in base 10, y'all, would be this number here in base 2. And that's what we basically did here. We broke it up into base 2, okay? So again, this is how we kind of, convert numbers from one base to another one, all right? All righty. So let me move on to the next one here, and it says, write for each of the following numerals, find B if possible. And if not possible, why isn't it possible, okay? So look, we got a couple of parts here. So part A says B1 in base 4 is equal to 25 and base 10. All right. So y'all, when I think of something like this, base 4 is equal to 25 and base 10 is just 25. But what I want you to think about is these are the ones, and these, in this case, are the 4s, okay? These are the 4s. Why the 4s? Because I'm dealing with base 4. So look, what I'm going to do is I'm going to say 4 times whatever my base is, right? Because I don't know what it is. That's a b, plus 1 is equal to the number 25, okay? Now, y'all, if I was trying to solve this problem for the letter b, the first thing I would say is let me go ahead and subtract 1 on both sides, okay, and get rid of those. And we're going to say 4b equals, say, 24, okay? And then I would divide everything here by 4. Yeah, and we would get b equals 6, right? So we would say that the b number should be 6. Now, y'all, the one thing I want you to notice, what base were we dealing with? Base what? Base 4. In base 4, y'all, the numbers that we use in base 4 are those numbers right there. We use the numbers 0s, 1s, 2s, and 3s because we never go past that number. We always go 1 before it. So if it's base 4, the biggest number I'm going to have is 3. But we're saying here that this number here should really be a what? A 6, but we can't do that, right? So not possible because 6 is not in base 4, right? Can't do it because 6 is not a number in base 4. Okay. All right, so there is a part B to that problem. So let's go ahead and take a look at part B. And part B says, what is 5b2 in base 12 equal to in 4,223 base 6? Okay. So again, y'all, I'm gonna start with the number in base 6 because I think it's gonna be easier for me to start off with. But I want to remind y'all of something, okay? When I'm looking at these numbers here, remember, these are my 1s. These numbers are the powers, are the 6 to the first powers. How many 6s do I have? That's going to tell me how many 6 to the second powers I have. And that's going to tell me how many 6s to the third power I have, okay? So first thing I'm going to do, y'all, I'm going to write out the right-hand side. So I'm going to say this is 4 times 6 to the third plus 2 times 6 squared plus 2 times 6 plus 3, okay? So I'm working with that right-hand side first, okay? Now I'm going to go ahead and figure out these numbers, okay? So let's take 6 to the third and figure out what that is. 6 to the power 3 is 216, okay? Let's see, 6 squared. 6 squared is 6 times 6. I know that's 36. I'm going to go ahead and write 12 and 3. Okay. And let's go ahead and start multiplying these numbers out. So first thing I'm going to do again is what's 4 times 216? That's going to give me 864. 2 times 36, y'all, is going to give me 72. 12 and 3, I already know is 15. And I'm just going to add up the rest of the numbers, okay? So let's see, 864 plus 72 plus 15 is 951, okay? 951. Okay, now, just like the way we did this part here, y'all, I want to do the same thing on the next part. Remember, for base 12, these are my 1s, okay? This is telling me how many 12s to the first power I'm going to have, and this is telling me how many 12s to the second power I'm going to have, okay? So look, I'm going to go ahead and write this out. So I'm going to say, look, this is 5 times 12 squared. This is b, because I don't know what the number b is, times 12, and that's a plus 2, okay? Question, anybody know what 12 times 12 is? 144, right? Okay, cool. So look, this is 5 times 144 plus, I'm just going to write this, y'all, as a 12b plus 2, okay? Next step, y'all, I want to go ahead and multiply whatever 5 times 144 is. Let me do this on the side. So 5 times 144. It's giving me 720. So I got a 720 plus 12b plus 2. Okay. And I'm going to go ahead and add these numbers together. So that's going to give me a 722 plus a 12b. Okay. Now, y'all, if I'm trying to solve for the letter B, I need to get rid of that 722. So let's go ahead and subtract it on both sides. Okay. And that's going to leave me a 12b equals, let's see, what's 951? Oops. 951 minus 722. That's giving me a 229. Okay. And what I want to do now, y'all, is just divide everything by 12. Okay. So 229, if I divide it by 12, look at the answer I'm coming up with. I'm coming up with like 19.08, and the 3 repeats, right? Y'all, the thing about my bases, they have to be counting numbers. They got to be numbers like base 2, base 3, base 4, base 5. This here is not a counting number. So we're going to say not possible. B must be a counting number. Right? It's got to be a counting number. So it can't be a decimal, can't be negative. It's got to be at least 2, 3, 4, 5, 6 or bigger. Okay? It's got to be that. Can't be anything smaller than a base. The base number can't be anything smaller than 2. So it's got to be 2 or more, but it has to be like a whole number, a counting number. Okay. All right. So let's keep moving along here. All right. Look, y'all, look at the next problem here. Let's see if we can figure this one out. It says, using the number keys on a calculator, fill the display to show the greatest 4-digit number if each key can be used only one time. Okay, so our number is going to have how many digits? It's going to have 4, right? So look, y'all, we're going to put 1, 2, 3, 4. Okay, so y'all, we want to make the biggest number that we can put. Okay, so if I think about my digits on the calculator, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If we want to write the biggest number, and each number can only be used one time, what number do you think we should put in that spot right there in order to make the biggest number? What number should we put in the first spot? Anybody know? 9. Okay, so look, y'all, we're going to use a 9. Now we can't use a 9 anymore because it says we can only use each number only one time. What would be the next number we should pick? Anyone know? What would be the next number we could pick if we want to make the biggest number we can make? If we already used 9, what do you think the next one would be? 8. Okay, and then 7, and then 6, and we got our number, right? So again, y'all, one thing I want to point out about this problem, if it's telling me to do the greatest 4-digit number, the first thing I did, I drew my little 4 lines, right? And then if I'm looking at the number of keys on my calculator, I'm just looking at the 10 digits that we have, right? 0 through 9. And if it says it needs to be the greatest, I can only use the numbers one time. Once I use my number, I can't use it anymore, right? So I'm going to go 9, 8, 7, 6, that kind of thing, right? All right. Okay, so look, y'all, this problem here, what we're going to do, again, just to get comfortable with writing numbers in different bases. What we have here is we have numbers that are in different bases, and what we want to do is we want to fill in the blanks, okay? So I'm going to start with part A, okay? I'm going to start with part A. I know what my number is in base 10. I want to see if I can write that number in base 3. I want to see if I can write that number in base 6. And I want to see if I can write that number in base 8, okay? So y'all, what I'm going to do, I'm actually going to leave part A alone for right now. What I want to do for parts B, C, and D, okay? I want to find out these numbers right here first, okay? I want to find out what those numbers are going to be first, and then once I know that, then I'll come back and I'll fill in all the other ones, okay? So look, let's take a look at this part right here. This is the number 2,111, but it's in base 3. So the first thing I'm going to do since this is in base 3, remember, these are my 1s, these are my 3s to the first, these are my 3 squareds, and those are my 3 to the thirds, okay? What I'm going to do, y'all, I'm going to write these numbers in base 10, and then we'll go back and do the other parts of it. So when I look at this part right here, this is telling me that I have 2 times 3 to the third. This one is telling me I have 2 times 3 squared. The next digit is telling me I have 1 3 and I have 1 1. Okay. So first thing is, what is 3 to the third power? So let's figure that out. 3 to the third power means 3 times 3 times 3, 27. Okay. Let's see. 3 squared is 3 times 3 is 9. Okay. And then the rest of it, y'all, it's just going to be some calculator work. 2 times 27, I don't even need a calculator. That's 54. 2 times 9, I know, is 18. 3 and 4 is 1. Now I'll go ahead and get my calculator for this piece just because it's easier. So let's see. 54 plus 18 plus 4 is 76. Okay. So for the first number, y'all, we found that that number is the same thing as 76 in base 10. Okay. Now, I'm going to play this game again, but I'm going to do it for the 423 in base 6, and then we'll write it in base 10, and then we'll come back and figure out all the other parts, okay? So let's see, 423 base 6, 423 in base 6. Remember, y'all, these are my 1s, these are my 6 to the first, and this is telling me how many 6 squareds I'm going to have, okay? So I'm going to say, look, this is 4 times 6 squared. This is 2 times 6 to the first, and then a plus 3 at the end. Okay. So 6 squared, I know, is 6 times 6, which is 36. Okay. 6 to the first is still 6, and 2 times 6 is 12. And then that's a 3. Okay. So let's go ahead and do this next part. 4 times 36. Let's see. 4 times 36 is 144. Plus that's 15. So 144, add 15 to it, 129, 159. Okay. So this is the number 159 in base 10. Okay. All right. Let's take a look at this last piece right here, y'all, and then we can come back and find the other values. But look, we have 20 in base 8, and we want to figure out how would we write that in base 10. Okay, so question, if I have 20 in base 8, does anybody remember what the first digit tells me? Those are my what? 1s, okay? And these here are my what? What would the second digit tell me? How many what? How many 8s I'm going to have, right? That's going to tell me how many 8s I'm going to have, okay? So look, let's go ahead and write that out. So if I have this is going to be 2 times 8 plus 0. Excuse me, what's 2 times 8? 16, and 16 added to 0 is still 16, right? So here we go. That there, y'all, is 16. So look, we've found out what each of those numbers are in base 10. Now that we have that, we can write our numbers either in base 3, base 6, or base 8, okay? So look, let's start with part A, and let's figure out, sorry about that, let's figure out what base, or what 60 is in base 10. What does that number look like in base 3, base 6, and base 8? Okay, so the first thing I'm going to do, y'all, I'm going to do this on the side because it's going to take me some time. Okay, if I'm going to go with base 3, I want you to think about the numbers that I have in base 3. I have 1s, I have 3s, I have 3 squareds, which are 9s, I have 3 to the thirds, which are 27s, I have 3 to the fourths, which are 81s, and I could keep playing this game. But I want you to notice something. When I said 3 to the fourth is 81, that number is already bigger than 60. So I'm not going to need anything bigger than 3 to the third. Okay. So what I want to figure out is how many times would 27 go into 60? Okay. So look, y'all, I could take my calculator. I could say 60 divided by 27 would give me 2 and some change, right? So what that's telling me is that this number here is going to be 2. Okay, how many 2s am I going to, or how many 3 to the thirds I'm going to have? I'm going to have 2 of them. Okay, now I could always figure out what I'm left with by saying, look, what's 27 times, 27. Come on, there we go. What's 27 times 2? That's 54. And 60 minus 54 leaves me with 6. Okay, so I have a remainder of 6. Okay, now that I'm doing this, I have a remainder of 6, because all I did is basically said 27 went into 60 2 times, that was 54, my remainder is 6. Okay, question, does 9 go into 6 at all? No, it doesn't. That's going to be a 0. Okay, how many 3s are in the number 6? Anyone know? How many times 3 go into 6? 2 times. Do we have any remainders? No, we don't. So 60 in base 3, y'all, is going to be 2020 base 3. Okay, so look, all I'm going to do is come back over here, and I'm going to write 2020 base 3. Okay, I'm going to play this game every single time, y'all, so I can figure out how do I write my numbers in different bases. Okay, so look, we're going to do the same thing now, but with base 6. So 60, if I'm going to write this in base 6, remember, I have 1s, I have 6s, I have 6 squareds, which is 36. Okay. Now, I'm not going to go past that because I know that whatever 6 to the third is going to be way too much. Okay. So the first thing I'm going to do, y'all, is I'm going to divide 60. I'm going to divide it by 36. Okay. So look, 60 divided by 36. 2 is going to be way too much. So I'm just going to go in one time. Okay. So 60 minus 36, that's a 5, borrow 1 from here. Okay, so 10 minus 6 is 4, 5 minus 3 is 2. Okay, so this went in one time. I have a remainder of 24. What I'm going to do now, y'all, is I'm going to take that number 24 and I'm going to divide it by the next number I have, which is 6. How many times does 6 go into 24? 4 times, right? And it goes in nice and neat, so I don't have any remainders. So my number is going to be 140 base 6. Okay, 140 base 6. So look, y'all, right here, I'm going to write 140 base 6. Okay. I know it's a little messy and it takes some time to do, but I can figure every one of them out. Now, I'm going to do the same thing, y'all, for base 8. Okay, so when I have 60, and I'm going to write that in base 8, remember what we have, y'all? We have 1s. Oops. We have 1s. And we have 8s, and we would have 8 squareds, which would be 64. But 64 is going to be too much. So I'm going to divide it by 8. 60 divided by 8 goes in 7 times. 56. Do we have any remainders? What's our remainder? 60 minus 56? 4, right? So what that tells me, we have 7 8s and we have 4 1s, right? Because how many times did 8 go into 60? When in 7 times, there was 4 left over. So this here, y'all, is going to be 74 base 8. Is this making sense how I'm doing this? Yeah? Okay. I know it's a little tedious, you guys. I mean, I'm not going to lie and say like, oh yeah, this is the most fun I ever had. But I'm just trying to make sure that everybody understands the process. Okay? So look, y'all, we got a more to do. We're going to deal with 159. We're going to go with base 3, and we're going to go with base 8 because we already had this piece right here. Okay, so look, let me take the number 159 and let's figure out how we can write that in base 3. Okay, so I'm just trying to work with whatever space I have. 159. Okay, if I'm going to go to base 3, remember we have 1s, we have 3 to the first, we have 3 squareds, which are 9s. We have 3 to the thirds, which are 27s. We have 3 to the 4th, which are 81, and we would have 3 to the 5th, which would be 243. Now, I already know that 3 to the 5th is way too big because the number we have is 159. So I know I'm not going to need any 3 to the 5ths. So I'm going to start with my 3 to the 4ths. What I want to figure out is 159 divided by 81. I think it's only going to go in one time, y'all, because 80 times 2 would give me 160. That's already way too much. So 81. So when I subtract, that's going to give me an 8, and that's going to give me a 7. So I have one of the 81s. Okay. Now I'm going to take 78, and I'm going to divide it by, say, 27. And I want to say it's probably going to go in, I think 3 times is too many. Let me try twice. So 2 times 7 is 14. Carry the 1 there. 2 times 2 is 4, and 1 more is, what, 5? So let's see. If I subtract now, let's see. That's 4 and 6, 14. Yeah, okay. So now I got 14. So this is going to be a 2 right here because they went in twice. Now I'm dividing it by 9. How many times might 9 go into 14? 1 time. And if we subtract, we're going to be left with 5. So there's 1 9. Okay. Now look at the next number I'm going to divide it by, y'all. Divide it by 3. Okay. How many times does 3 go into 5? Once. Okay. With a remainder of 2. So that's 1 there. And how many units do we still have? Whatever that remainder is. Okay. So here's my number in 159 in base 3 is the number 12,112 in base 3. Okay. So again, y'all, all I'm going to do is come back over here and say this was 12,112 base 3, right? Yeah. Okay. Okay. Got to do this one more time. 159 for base 8. Okay. So let's see if we can figure that out for base 8. 159 in base 8. Remember, we have 1s, we have 8s, and we have 8 squareds, which are 64s. And I don't think we need to go more than that. Okay. So let's take the number 159, y'all, and let's divide it by, say, 64 in this case. I'm going to say it's probably going to go in 2 times. 2 times 4 is 8. 2 times 6 is 12. And if we subtract, let's see, 9 minus 8 is 1. 5 minus 2 is 3. So we end up with 31. Okay, so we have 2 8 squareds, right? All right, now I'm going to figure out 8. How many times is 8 going to go into 31? Okay. So 8 goes into 31 probably 3 times, because that's 24 with a remainder of 7. So that's going to be a 3 right there. And my remainder, y'all, is telling me exactly how many 1s I'm going to be left with. So my answer here is 237, right? 237. So I'm going to just scroll back over here and write 237. Okay, so look, we got one last part to do. We got to do 16 for base 3 and 16 for base 6. So let's see if we can't figure this thing out. So 16 in base 3, remember we have 1s, we have 3s, we have 3 squareds, which are 9s, and I don't think we need to go past 9, okay? So first thing I'm going to do, y'all, I'm going to take 16 and I'm going to divide it by 9, and I want to say it's going to go in 1 time. And I got 7 left over. So I know I have 1 9, okay? Now I'm going to take the number 7 and we're going to divide it by, in this case, 3. How many times might 3 go into 7? Anyone know? 2 times. Very good. 6, okay, with a remainder of 1. So this is going to be a 2, and that's going to be a 1. So now I have 121 base 3, right? So look, y'all, I'm just going to write this over here, 121 base 3. All right, and I'm going to do this one last time. So 16 in base 6. So let's see if we can figure out 16 in base 6. So 16 in base 6. Remember, we have 1s, we have 6s, and we have 6 squareds, which are 36. And I don't think we're going to need those because that's going to be way too big. Okay. So look, let's take 16 and let's divide it by 6. It's going to go in 2 times with a remainder of 4. So I have 2 6s and 4 1s, right? And so y'all, all I'm going to do is come back over here and I'm going to write 2 6s and 4 1s. And again, that's in base 6. So it's tedious. I don't want to lie. I'm not going to tell you it's, you can get it done in like 5 minutes. It's going to take some time to do. Oh, did I miss 76? Right? I forgot 76. All right. Okay, guys, we'll do 76 right now. I don't know why I forgot to do 76, but we'll do 76. I don't know why I thought I had done it. All right, so let's do 76. We still got to do 76 for base 6 and base 8. I just forgot that one. Okay, so 76, let's do base 6 and base 8. All right, so 76. Sorry, y'all. 76. We want to go with base 6. So we have 1s, we have 6s, and we have 6 squareds, which are 36. I don't think we need to go past that. So let's see, 36 into 76. We'll go 2 times because that'll give me 72. Okay. Now, if I subtract 76 minus 72, I have a remainder of 4. So I have 2 6 squareds. Now, the next part I have to ask myself is, does 6 go into 4? No, it doesn't. So I have a 0 right there, and I'm going to have 4 1s. Okay, so 76 in base 6, y'all, would be 204 base 6. So again, I'll just scroll back over here, and I'll write 204 base 6. And then we'll do exactly the same thing for base 8. So 76 in base 8. Okay, so 76 in base 8. Remember, we have 1s, we have 8s, and we have 8 squareds, which are 64s. So I'm going to start with 64. So 76, oh, come on, pen. 76 divided by 64 is going to go in 1 time. Okay. And if I subtract, that's going to leave me with 12. So I have 164. Okay. Now, if I'm looking at number 12 here, y'all, the next thing I'm going to divide it by is 8. So I'm going to say, look, 8 goes into 12, what, 1 time? With a remainder of 4. So there's 1 8, and then there are 4 1s. So 76 in base 8 would be 114, base 8. So again, I'll just scroll back over here, and we will write 114, base 8. I forgot to put my 8 right there. Okay. And we got it. So again, y'all, it is tedious. It is kind of a pain to fill out this table because it does take time to do. But I'm hoping that after we've done, I don't know, a whole bunch of these things, however many there were, 1, 2, 3, 4, 16 of them, because we just did 16 of them. I'm hoping that the process makes more sense, okay, and how we're doing it, all right? So y'all, that is 3.1. Wednesday, we will continue and we'll go with 3.2. And we'll figure out, like, how do we add numbers in different bases. We'll talk about closure, and we'll talk about commutative properties and all this kind of stuff. But we'll talk about, partial sums and all this kind of other stuff too, okay? So anyway, I know the base stuff is probably very new, y'all, because we probably saw it when we were, again, 1st grade, 2nd grade, 3rd grade type stuff. But it's been a long time. And so it's kind of like we're learning it for the first time again. At least I feel like that's kind of what we're doing. But anyway, I hope this stuff made sense. You guys, if y'all got questions, please let me know. I'm happy to help. Let me go ahead and stop recording. Boom.